Hi everyone, my name is Sitesh Adhikari and I am participating in this Build for Bharat hackathon. So I have chosen a price optimization engine to go with, and I want to begin with a Nifty 50 index chart as you can see over here. So if we want to predict the next day closing price, it is quite impossible task or quite a difficult task, even if we have done some advanced analysis. But if we are given a setup period, say for say next 5 years, we can predict the price movement and can determine whether the price will meet our expectations, right? So all indicators are the lagging indicators. A 1 hour candlestick chart, a 1 hour candlestick indicator, a candle will not close until the price action takes place for an entire 1 hour. Similarly, for a month candle indicator, a month candle will not close until the 29th day of initiation date. And until the closing price, one cannot derive the candle closing pattern, even we have set up 30 years of data. It is hard to predict the next day closing price precisely. Therefore, solution to the problem statement of this hackathon should be found somewhere between the algorithm that I designed and the data I acquired from the market. The past data may entirely comes from the situation and the circumstances of the previous factor. The tomorrow the situation can be different altogether. Since I need to derive the upcoming selling price from the market itself, which is not the range of prices from where I can predict the market movement of the market, I decided to go with the solution which is ahead of time and still the data driven solution of that particular time. Similar to the AI driving car. AI driving cars can get the help of previous data to learn from it, but cannot depend entirely on those data, because what is going to be faced on the road can be entirely different from the previous experience and learning. So there we need to work on set of algorithm which helps our AI car to take the decision ahead of time. Depending upon our above scenario, I decided to go with the Flutter application, which is also my area of expertise. First, I set up the environment setup application. You can see over here. Environment setup application. This application is to set up the background environment task, which may impact the buyer and seller selling price decision, or buyer or seller price fixing decision. This is only one of the approach that can suggest the varying price of the grocery items to the seller. There could be the combination of such multiple approaches and algorithms that we can work on to decide the closest and the healthiest selling price recommendations. You can see over here we have 3 apps. The first app will represent the environment setup app. This is a simulation to the environment setup. This is a simulation to the seller setup, and this is a simulation to the buyer setting app or buyer setup. So the Google Bart says the estimated number of households in Gangtok as of 2024 is 23,773. This data comes from the 2011 census report, which is most recent official data available on the internet. However, it is important to note that this number is likely to underestimate, as 2021 census scheduled for Gangtok has been postponed due to pandemic. It is expected that the new population census will be conducted in 2024 and the official number of households will be updated then. The population of Gangtok is estimated to be around 1,40,000 in 2024 and the radius of Gangtok is around 2.2 kilometers. This data helps us getting the average household member the average household member, which is 5.8, which is equivalent to 6 in Gangtok. You can see over here the 6 members per family household. We have 6 members in Gangtok, and the total number of you can say household itself is a 23773, the official data, and within a 2.2 kilometer of radius. Within same radius, we have here we have made some assumptions. So these environment variables are self-explanatory, like these environment variables, whatever we have mentioned over here. The city, the first Gangtok city, place is MG Marg, unit, you can say unit of kg, base price of the grocery, and max price of the grocery, household rate, initial radius of the place, maximum radius of the place. So these are the environment variables. These are also self-explanatory variables, and I manually supplied these values for this demonstration. Later these values can be derived and replaced from the Google Map data of the buyer app. Official census website scraping data from the different sources and when adding the grocery items. So this data can be collected from the different sources. First source will be of Google Map itself, and second will be a buyer application. From will get the buyer whatever data we're getting from the buyer application, official census websites, scraping data. So these are the data sources that we can get from on a real-time basis when we launch our application in a real time. Number of household per square kilometer within a Gangtok area is 10805, which is derived by dividing household numbers divided by radius of Gangtok. Considering this a standard number, first slider to the environment setup first slider in an environment setup app, upon changing the value in kilometers, if you change this value in kilometers, see what will happen. First, the number of households changes with changing distance. Number of household changes with the changing distance. Here we have considered the number of households is equivalent to number of searches, right? We have made assumptions before. And second, within the price indicator, this is an indicator, not a slider. The second one is an indicator. I have disabled this thing over here. Okay. So second, within the price indicator, the number of searches and the distance in a kilometer, and thus the price is adjusted accordingly. Second, within the price indicator, the number of searches and the distance in kilometer changes with the changing in kilometers. This slider. Okay. Here, the number of searches is equivalent to the number of household, considering each household cooking food under the same kitchen, and only one person is searching the item at that particular time. Okay, these are some assumptions that I have made. With the increasing distance, household number increases, and thus the searches number also increases. If there is only one mandi in that particular area, assuming the supply source of the grocery is limited, the price will increase with more household demand. Here I tried to demonstrate how the price of the grocery gets affected upon changing the variables of the market. This assumption demonstrates the price impact on the grocery stores and sabji mandi. Since the demand supply can itself limiting to the many factors, here I made maximum X increase X increase with 1 kilometer radius change or increase or decrease for a small town like Gangtok. The increment and the decrement of this variable entirely depends upon environment variables mentioned below. We'll note that later. These variables not only decide the incremental rate but also decide the base price of the item, which may be high or low. value change which will impact the price. Just this is just to demonstrate the features. It can be low or high depending upon market to market, but this can be changed later. Of course, these variables can be changed in real time scenario. Here I made an assumption to demonstrate the clear picture to the changes. These values also depend on the process of delivery expenses of if the grocery is bought from the e-commerce platform, available logistics in the area of demand, distance from the order item, and so on. Therefore, each variable mentioned here needs more attention and needs to turn out to be more effective algorithm. For this demonstration, I kept the value default, and I kept the default and the same weightage for all below variables, like a public opinion poll with 10 a max value and 0 a lowest value. The variables are mentioned below. You can see over here. So this is the first screen, right? And if you click over here in a settings tab, this button, setting button, you can manually change these items. Change this variable from 0 to 10, same as a public pool. More the variable, the more will be the increment. Less the variable, less will be the increment. So what are these variables? Transport availability, modern farming education, storage availability, wastage management, seasonal farming, water supply availability, production per unit, favorable weather condition, and organic farming, quality of seed, so on and so forth. So these are the variables which unchanged will affect this rate of increment or decrement. Okay. So right. So in the real case scenario, the calculation can be performed considering many different factors inside the back end of the application, which with the help of data accumulated in the database, we can perform the complex calculation to derive the actual algorithm. Cost of transportation can be derived from the local transport services. Farming awareness and education can be derived from the public opinion pools. Storage capacity from the individual or manually visiting to the site, and so on and so forth. All variables are not only limited to above mentioned variables, but also the real time scenario. It depends upon the real time scenario of that particular area. This is the best case scenario for the small town like Gantok. The larger city like Mumbai and Delhi, more things need to be taken into consideration. Like maximum radius should not exceed more than few kilometers, assuming within every 10 kilometer radius there is another sabzi mandi or a retail store. So this is the second application. This second application illustrates the average buying price. You can see over here average buying price, which is derived from summing all buying prices, dividing it with number of buyers. So this is the average taken from here to here. So when we made a change over here, it will save the change into the Firebase real-time database over here. See over here, like if I change this anything over here, if I made a 3.5 kilometer over here, the distance will, the price will change. That is 265, and same 265 will stored over here, and the same will be reflected over here in a seller app, the 265. Here I consider the seller app will operated by the ONDC. This app will be operated by the ONDC and not by the seller themselves. This ensures ONDC the reasonable profit margin to the manufacturers or farmers, distributors or retailers, or any distributed network members, considering all inbound factors. With the help of seller app, ONDC can decide if the suggested price gives the distributed network a reasonable profit margin in case the suggested price is not aligned with the profitability of the distributed network. ONDC can themselves adjust the price if it is not aligned with the profitability. The adjusted price is the final and shown to the buyer app. Suppose if this price coming from the environment application, if this price is not at par the, if this price is not suitable for the buyer app, they can fix this, ONDC can fix this price manually. So if I make this value to, say for example 170, then same will be stored in the database and same will be reflected here on a buyer app 170. So apple price is, here grocery is apple and apple price is 170, and same will be shown over here in the buyer app. So here the environment app to seller app and seller app to buyer app. So this is the sync, this is the sync between three applications. So I have also included a timer for each item price recommendation. For this prototype, I made a price expiration every 10 seconds for each item. Suppose if I made any changes over here, that will reflect over here, as well as the timer will be set for 10 seconds, and after 10 seconds the price will expire. You can see over here price expired. So after that ONDC will have to manually adjust the price accordingly, and then only then the timer will start. Expiration timer is also triggered when starting the seller app for the first time, and when the buyer price is assigned to the buyer application, to nullify the time lapse between the expired time and when the ONDC updates the buyer price, so that environment setup app would give the search count updated on a real time. So this is the seller app, this is the buyer app, and this is the environment app. So these three apps are synced between each other. There could be the different algorithm trial and tested to fit the exact market need. So this is not only one algorithm that works in this environment. There could be the multiple such algorithm and calculations, to fit the market need. And which may cause grocery production on a year-on-year basis. So like there could be the different algorithm trials and tested to fit the exact market need depending upon all factors which may cause grocery production on year-on-year basis. May it be weather condition for that particular year, transportations, wastage management, quality and quantity of fertilizers used, storage capacity and available resources, manpower needed for that particular production, and so on, which may cause the direct or indirect effect to the cost of grocery, as well as the base price of the grocery and the increment of the grocery as well at that particular time. In my opinion, these assumptions are applicable in all case scenario because the selling price is derived from the demand of the market considering all above factors. especially when it comes to grocery items. Like, in my opinion, these assumptions are applicable in all case scenarios because the selling price is derived from the demand of the market considering all above factors, and the market itself decides the demand and supply zone, and no other factor could, especially when it comes to grocery item. An efficient architecture is not to memorize the past event and to derive the outcome out of it, but an actual efficiency is when an application reads the currently available data from a large number of people in a real time and comes out with a more robust outcome which decides the future of the market. Said this, the real time data is actually more efficient than the stored data, not just to derive the complex algorithm but to change the future of the market. The market moves basically on the herd mentality, when the crowd will decide the direction of the market. The fact is also a little bit harsh if these data are driven by the single entity, which I hope will be taken care with the help of blockchain technology in a later days. So that is all about my presentation here. Thank you for listening and have a great day. Thank you.